All right, gentlemen, let's try this again. Computer froze the first time. Yes, good time. So today we're going to talk about direct variation. Direct variation is when a linear relationship, linear means straight line, like the blue picture, has a ratio of y to x and it's a constant ratio. For example, I see I have a constant ratio of 2. Now, this is where the computer froze last time, so here's to hoping it doesn't. If I start at 0, 0, there we go. Just need to make it a little bit larger. Perfect. And then I go up to, yay, we work out it, up to over 1. I see that it meets again, and then up to over 1 more, and then up to another one, and up to another one. I have a constant relation of 2, where that constant relation, that constant slope is causing me to go up 1 and then to the right one. Or I'm sorry, go up 2, then to the right one, then up 2 to the right one, then up 2 to the right one. And it keeps constantly doing that. It does not change. So direct variation has to have a constant relationship. A key part of being it is it has to be a straight line, but not all straight lines are constant. So we will be able to determine that here coming up, whether it's direct or not. So number 1, the height of the pool of water, the height of the water as a pool is being filled is shown in the graph above. Determine the rate in inches per minute. So it wants me to find inches per minute. So I have inches over minutes. So let's see what happens. How much do I increase upward? Well, I can see between this dot and this dot, because those are just the 2 I chose. I end at 4, started at 2 with my height, and I ended at 10, started at 5 with my time. 4 minus 2 is 2. 10 minus 5 is 5. Now, I want to make that as small as I can, so I'm actually going to take 2 divided by 5, which is equal to 0.4 for 1. So I can say, and I'm going to type because we all know what my handwriting looks like on my computer screen. Oh, and let's keep with the color scheme. So essentially we're finding out that the pool is filling at a constant rate of 0.4 inches every minute. Cool. 2 minutes after a diver enters the water, he has descended 52 feet. After 5 minutes, he has descended 130 feet. What rate is he descending? So in this one, we're talking about minutes and feet. So I have minutes per feet. So I have 2 minutes and 52 feet. And then I have 5 minutes, there it is, and 130 feet. And let's think about that. When we're doing something at a constant rate, we always have time on the bottom. So I'm going to take my feet per minute. So 130 minus 52 over 5 minus 2, which gives me 78 over 3, which is he descends. Oh, I cannot type today. He descends at a rate of 26 feet per minute. All right, next idea, next kind of general idea. The equation y is equal to 10x represent the amount of money y Ooh, that's important. I'm going to go back and highlight that. Money is Y. Julio earns for X amount of hours of work. So X represents hours of work. Identify the constant proportionality. Identify the constant of proportionality. Explain what it represents in this situation. So this constant proportionality is 10. He's the guy that's multiplying or being the multiplier of the amount of hours per week. And in this case, what does it represent? It represents Julio earning $10 per hour of work. The distance y traveled in miles by the Chang family in x hours is represented by the equation y is equal to 55x. Identify the constant of proportionality, then explain what it represents. Okay, let's go back again and highlight. So y is distance and x is hours. And let's think about this distance as hours is kind of like miles per hour, right? Oh, hey, look at that. So the constant of proportionality is 55. And because we know that everything is miles per hour and we're going to assume we're in the US, the Chang family drove 55 miles per hour. All right, determining direct variation. Not all situations with a constant rate of change are proportional relationships. Likewise, not all linear functions are direct variations. So we're going to see some examples that might not be. Pizzas cost $8 each plus $3 delivery charge. Show the cost of 1, 2, 3, and 4 pizzas. Is there a direct variation? So remember when I said the book online when I cut paste things because it's a lot easier than having me to make it? Already has some of the things done, so it was nice, and I cut the chart out because I'm nice like that. And I already had it graphed because again, it was easier. Oh. And I realized I'm in my PJ pants. That was cool. So, is there a direct variation? So to determine if something's a direct variation, we start by taking and identifying how each piece changes. So the cost of one pizza is $11 or 11 per one. The cost of two is 19 for two, which that can't reduce. The amount of three is 27 for three, but that could reduce to 9 over 1. And then lastly, I have the cost of 4, which is 35 for 4, which again doesn't easily reduce. So even though this is a straight line, it's a linear representation, my proportions for each dollar amount per amount of pizza are not constant. So for this example, I can with very good certainty say that there is no direct variation. Because the rate at which I would pay for each pizza as I increase is not consistent, there's no direct variation. Man, those sneezes serve me off. Whew. All right, next one. 2 pounds of cheese costs $8.40. Show the cost of 1, 2, 3, and 4 pounds of cheese. Is there a direct variation? Explain. So I'm gonna go ahead and just make this. I've got the weight, And, oof. I've got the cost for money. I've got 1 pound, 2 pounds, 3 pounds, and 4 pounds. So it tells me that 2 pounds cost $8.40. So I'm going to have to go with, since that's the only thing I'm given, it's not saying it increases any amount, it just says 2 pounds is $8.40. So I'm going to go ahead and say that 1 pound is $4.20. So then, likewise, 3 pounds must be what, $12.60? And 4 pounds would have to be $16.80. And then we're going to graph it. So 1 pound is $4.20. So there. 2 is $8.40. So like there. 3 is $12.60. So like there. And 4 pounds is $16.80. Now again, my dots are not in the best spot. Trying to do this on a computer, not the easiest thing. I can definitely hand draw this a lot better than what I just did. I'm not terrible. I think I'm going to try and make it a little bit more accurate by... Yeah, it's about there. I'm going to make it a thinner line so we can see my dots. Haha. Here we go. See? Much better on paper. Straight line on paper. So let's talk about the price per pound. Well, 1 pound is $4.20, 2 pounds is $8.40, which could reduce down to $4.20. 3 pounds for $12.60, again, reduces down. So this is a constant rate. All right, last one. Determine whether the linear relationship is a direct variation. If so, state the constant of proportionality. So when I deal with time and wages, think about this. I've got money over time. I always discuss the amount of money I make per an hour. So we know that my money needs to go on top. So I have money over time. So I have 12 over 1. That can't reduce. I have 24 over 2, which could reduce down to 12 over 1. I have 36 over 3, which could reduce down to, sorry, I meant to write an equal sign, which could reduce down to 12 over 1. And I have 48 over 4, which could reduce down to 12 over 1. So yes, this is constant. I'm, again, increasing at the same rate. So yes, it is a direct variation. The constant of proportionality. I always want to put way too many i's in there. Is 12 over 1. Or 12 divided by 1. Same thing. I'm actually going to write 12 over 1. All right. I thought that was pretty easy peasy lemon squeezy based on our slope and our really, really, really focused lesson of whether things are proportional or not. So after this, notes, we have some homework, and then we have chapter test 1. Woohoo!